Okay, we're going to work through a second example here of proving triangles similar. So take a look at what we're given. We have two triangles. We know they're right triangles. And then we also have this funny looking equation that we're given, or proportion. And we're going to see how we can use that, what that actually tells us. So getting started here, let's just do some setup. Okay, getting our given information down. And that was supposed to look like a triangle. Looks a little bit better. And even if you're totally confused on proving triangles similar, we should know something that we can do with that statement that we have right triangles, because that's not an unfamiliar thing to us. So right triangles, I want to say that I have right angles so that I can say they're congruent. Because I ultimately want to have a congruent statement whenever we're talking about angles. We want to be saying angles are congruent because corresponding angles are congruent in similar triangles. Part of my definition of similarity. So I know in this case that angle Y is a right angle. That was marked for me, and angle B is a right angle. And that really comes from my definition of right triangle. A right triangle is a triangle with one right angle in it. So I've identified that I have a right angle in each of those triangles. Not good enough. I want to say that I have congruent angle pair. So we have two choices right now. If you remember your right angle theorem, that allows us to say that angle Y is congruent to angle B right now. If you don't remember that, or you don't like to use that, then you would need to say that the measure of angle Y is 90 degrees and the measure of angle B is 90 degrees. And then set them equal to each other using your substitution property. So let me show you what I mean by that. Option 1, angle Y is congruent to angle B. And that gives me my nice congruent statement that we had two of in our last proof. Other option, so not to make this longer than it has to be, but if you're not familiar with that theorem, then we could be saying measure of angle Y equals 90 degrees, measure of angle B equals 90 degrees. By my definition of right angle, since I have a right angle there and a right angle there. So this would be a 3A step. And then 3B would be measure of angle Y is equal to measure of angle B, substitution, or transitive property. Okay, so either one of those would work. Moving on, I've got one pair of angles congruent, and the next thing I'm going to do is look and see if I have any other angles congruent in this problem. So looking back at my picture, the angles aren't connected. I don't have vertical angles. I don't have parallel lines. So I'm out of luck. I've only got one pair of angles congruent. So thinking back to our shortcuts, angle-angle similarity we're saying is not going to work. Other ones, we had our side-angle-side similarity, and then we had our side-side-side. So it's going to be one of those two. We already have that one angle. So I'd say that this one's a good option to try to go for side-angle-side. And the other thing is that I only have information about two pairs of sides, and that's right here because I only have two ratios. So, in fact, side-side-side would be impossible in this case because I don't have anything about the third sides. Let's go ahead and write down that proportion and see what we can do with that. XY over YZ is equal to AB over BC. So given information, XY over YZ is equal to AB over BC. Maybe you already wrote that in your proof, that's fine. I just didn't need it yet, so I hadn't written it down. And if we take a look at that, I'm not crazy about the way that's set up. Let me explain. XY and YZ are actually two sides within the same triangle. That's what I have on the left side here, XY and YZ. And then on the right side, I've got, let's go with a different color here, AB and BC are my two sides in the other triangle. But I really want to have ratios of corresponding sides, as in one in one triangle, one in the other triangle. And I want to show the two ratios are equal to each other. Now, technically, you could argue that what we're going to end up with are equivalent proportions. But I'm going to force you to make the habit of always putting one side of one triangle with one side of the other triangle. Because the problem is when we do go to use this third case, we can't be matching up two sides in one triangle, because then what do we do with the third? So we're always going to be matching up a pair of sides, and then if we have a third one, we can match up the third sides. So I actually want to make my next step just a rearrangement of my proportion that I have here. So I'm going to go ahead and keep my XY, but then I'm going to put AB in the bottom. And I know my picture's not showing right now, but take a look at your picture, and hopefully you'll agree with me that I've now matched up a pair of corresponding sides between the two triangles. YZ and BC are my other pair of corresponding sides. And if we look at that, I'm going to ask you, how do I know that's true? And hopefully you can agree that yes, that is true based on what we have in step 4. But our reason might be a little bit trickier. We haven't done this before. We briefly talked about equivalent proportions being proportions that have the same cross product. So if you look here, I've got XY times BC and YZ times AB, XY times BC and YZ times AB. Their cross products are the same, therefore we would say that the proportions are equivalent. So we're going to write down for a reason that we're using a property of proportions to write an equivalent proportion. Okay, we didn't list them out and give them special names, but we talked about equivalent proportions, or you could write down equivalent proportion, would be fine as well. Now, that actually counts double, so when we talk about our shortcuts in our congruent triangle chapter, I was really specific that if you're using a 3-letter shortcut, you need 3 letters, as in 3 congruent statements that go with it. And I know I actually do have 2 statements about sides here, but what I want to point out is that this one right here counts for both my S's. Your S's are going to come together when we're talking about similar triangles, because I'm not making separate congruent statements. I've got 2 pairs of sides that are proportional. They're always going to come in the same step, and they're right there in step 5. So I actually now have my side angle side that I was going for. So I've got my side angle side shortcut, and I can finish this proof off by stating the triangles are similar. Of course, that was your proof statement here. Triangle XYZ is similar to triangle ABC. And that would be an example of how we can use one of our shortcuts that involve the sides. Now, if we had side, 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 we would have a proportion and extended proportion where we had actually 3 ratios right here. Okay,